Okay, again, this still last one on the circle theorems. This time, let's see what we've got, and that's going to help us understand what we need to do. So always thinking about what we've been given. So this particular time, we don't have a diameter, so there's not going to be any triangles in a semicircle because we don't have a semicircle, but we do have a radius meeting a tangent. So we know a radius meets. You don't need to write this down. I'm just writing this down. This is what would be going on in my head. Radius meets tangent at 90 degrees. And here's another one. There's another radius. There's another tangent. Okay, so I know I've got some radii and tangents which meet at 90 degrees. Looking at the question again, I also notice that I have some lines leaving the same point on the circumference, heading to the center and the edge. So I know I'm going to be using my angle at center is double that on the circumference. So I've kind of scoped out the question. I know already what I'm going to need to do, really. So let's see. So first of all, to make it clear so this is now what I would be writing in the exam. So I would be saying, right, I would mark on my right angles here nice and clearly so the examiner knows that I know that these are both right angles. I've drawn now a quadrilateral, haven't I? It's not a cyclic quadrilateral, but it is still a four-sided shape. So I know that this angle here I can calculate. So that angle, and I would write out my method just so the examiner knows that I know what I'm doing. So this angle here is going to be 360, take away 90, take away 90, take away 44. So that's 360, take away 224, which is 136 degrees. Okay. So that angle at the center there is 136 degrees. I've used my red point pretty well there. And now I'm going to use my green fact. The angle at the center is double the angle at the circumference. So again, I would make sure to write down x equals, I wouldn't just write 68. If this was a calculator paper, I would obviously just do it on my calculator. But if this is a non-calculator paper, I'm going to write down what I'm doing, even if I am doing it in my head. So 136, just so they know that I know the method is to half the angle. 136 divided by 2, which is 68 degrees. In this question, technically, hang on, I'm going to go back to that previous one that Luke was asking me in a second, but the value of x. So it says on the diagram, x degrees. So x itself is just 68, technically speaking, isn't it? X is just 68 because on the diagram it's saying what is x degrees. So I don't need to write degrees there. Let me just double check what this question was. Yeah, and sorry, yeah, back to this one. Because it says x degrees, find the value of x. X is technically just 32, isn't it? But it doesn't matter either way, really. You can put 32 because it says find the value of x. It's a subtle point, and yeah, you would be fine. You would absolutely be fine either way in this case, but there's no harm in it. Does that make sense, Luke?
Yeah, that does make sense. Thanks, Joe. It's like I said, it was just with a few of them, the units are there, some of them they're not. So I'm just
Yeah,
wondering if it's important that obviously you add the degree. I know it's obviously important to have the degrees in.
yeah.
However,
But yeah, no, yeah. Yeah, if you're being kind of what's the word? Like extremely factually correct, because the degrees is there and it asks what is X, the technically correct thing to do would be to not put the degrees actually. But yeah, doesn't
because
matter.
X has degrees already on it.
Yeah, because it's saying what is X? X itself is just 32 because the diagram has the degrees there for you. It's yeah, it's a bit of a you'd be fine either way to be honest. Yeah. So then this one, 68 degrees, so we can put 68 or we can put 68 degrees up to us. So yeah, and then 3 marks. Have I done 3 marks worth of stuff? I've demonstrated that I know that these are right angles. That's a mark in itself. I've demonstrated how to calculate this angle in the middle, which I know was important. And then I've demonstrated that I know the angle fact to use here. So yeah, I have done 3 marks worth of work there. So I've not missed anything, I don't think.
So in that question that you've just done above there a moment, knowing that, as you mentioned, the opposite degrees is worth double or half, is that
Yeah.
something that you just need to know, or is that
Yeah,
a
yeah.
is that
That's just
given?
something you need to know. There is a list of circle theorems that you just need to know. So you need to be aware of these facts effectively. You need to know that if you have a circle, you need to know that if that is 2x, that is x. There is a long there's a way to prove why that is the case, but it takes a while. So, but
Long-winded.
it's worth just knowing. So you need to know that. You need to know that if it goes through the middle, that will be 90 degrees, kind of for the same reason as this, because this is then 180, isn't it? You need to know that if you have a shape bouncing around the inside like that, if that is x, this will be 180 minus x. And you need to know that for the same reason as this, if this is x, then that would be the same x. So these are just called the circle theorems, and these just need to be known, really. So you need to know these facts as well as this one. If you have a radius that meets a tangent, then that will meet at 90 degrees. And finally, you need to know that if you have two tangents to the same point, that was meant to touch, but never mind. Then this is clearly 90 degrees. This is 90 degrees. This is the same length as this. And importantly, this is the same length as this. Okay, so these 6 things, they're known as circle theorems, and you just need to know them. And then once you kind of know them, it makes the questions quite, you can tell more or less by which features are in the question, which of these theorems you're going to need to apply. So if there's a four-sided shape in there bouncing around the whole thing, it's going to be this one. If there's a line going straight through the middle, it's going to be this one. If there's different lines coming from the same points going to the center and the edge, then it's going to be this one. And if there's a radius and there's a tangent, it's going to be that one. So you can, once you know these 6 different things, you can look out for the features and just go from there, really.
And this is not provided in the exam. This is just
No, no.
expected to know.
That is just required knowledge, yeah. That is like the same thing as I suppose in maths, there's not so many things that are just you need to remember this list of things, but certain things you need to know, like certain values of trigonometric ratios, the circle theorems, various other little formulas here and there. I'd say there's a list of maybe one page full of stuff, and this if you're doing the higher paper, then yeah, this is what you need to know this stuff. Yeah.
Okay. All right.
Yeah.
Thanks, Joe.